Okay, here's our video today. The chord segment theorem. It's also known as the intersecting chords theorem. And basically, in simple terms, it's just when two chords, and you can see them in the picture. Let me get my pen working. So, when two chords intersect inside a circle, as you can see here, right, the pen's working here. Here's a chord going from A all the way to B. And there's another chord here in midpoint M, and you can't see the rest of it. Well, let's say it's going to there. So you have two chords intersecting inside the circle. And the product of the segments of one chord equals the product of the segments of the other. Well, let's get some examples here. So I'll draw a chord. I'll draw two chords, that is. Let's say, and see if my pen's working. Fix that. We'll use that color. So let's say I draw a chord coming here, and let's say I draw another chord connecting here. They're intersecting, and let's just label them. We'll say that this is 6 units, and we'll say that this is 4 units, and let's say that's 8 units, and we'll put an X here because we don't know what that is. Well, according to the theorem, right, if we take the products of one chord, this chord here, and we'll call it AB, chord AB. So we say the product, A times B, has to equal the product, and we'll call this CD. Has to equal the product of CD. So we'll say 6 times 4 has to equal 8 times X. So this is 24, has to equal 8X, and so it's just some algebra, and we know that X has to be 3. X has to be 3. All right, so because we know that 8 times 3 is 24, and 6 times 4 is 24, so that's how we got that one. So let's do some more examples. So this time, let's put a center. We'll put the center there. We'll call it P, and let's have another chord coming right through the center. Let's say it's going through the center. Pretend it's straight. And then let's say we have another chord up here, just like before. And we can label them. We'll call them A, B, C, and D. Doesn't matter, the letters. So let's say this was 2. And we'll say that this one was 4. Right? Actually, let me fix that. Let's make this actually X. We'll call that X. And we'll make that 2. And let's say that this whole line here is 6. So how can we find X based on the theorem? If you want to pause the tape and give it a shot, what do you think? So what we have for this line segment AB, we have 4 times X. And we know the product of that has to equal 6 times 2. 6 times 2. So 4x has to equal 12. And just doing a little algebra now, we know x has to be 3. Now, we can go a little further here. Let's say they asked you to find the radius. Find the radius. How could we do that? Well, we know, now, we're looking at CD. It goes right through the center. So that means that any line from the center out is a radius, or we say radii. There's radii. If we look at other colors here, we know from that's a radii and radius, and altogether plural it's radii. So I'm just creating anything from the center will be the same length, will be the radius. So we know that 6 plus 2 is 8. We know that in the segment CD, line segment CD, it equals 8. And the midpoint will be halfway, right? The midpoint will be halfway, so just 8 divided by 2, we know is 4. So we know that the radius of that circle will be 4. And of course, we didn't put any measurements. We'll just say 4 units. Let's do some more. All right, change the background a little purple there. Looks like the moon from Bewitched. If any of you remember that TV show, goes back a ways. Well, let's make a line. Let's make a chord. Here's our chord. It's going down there, let's say. And we'll have another chord. Let's say this chord just cuts right through here. And let's label them. Let's say that's 8. Let's say that's 24. And let's say this is 12. And let's say this is, what should we make this one? We'll make this 3x plus 1. I'm going to change it up. 3x plus 1. So you know the theorem, right? Why don't you pause the tape, see what you can do. So now we have here, we're going to have 8 times 24. That's this segment of the chord, that segment of the chord. We want to get the product of it. And it has to equal 12 times 3x plus 1. So I'm sure you did that. So 8 times 24 is 192. And if we did 12 times 3x, we're going to have 36x. Remember, we're distributing this plus 12, and it's just algebra here. So if we minus the 12 on both sides, minus the 12 on this side, put a line there. Now we have 180 equals 36x. Divide 36 on both sides. Just doing algebra. And we know now that 5 equals x. So we found out what x was. So let's do one more. Let's do one more that's a little harder. Let's clear it out. Let's keep the bewitched theme. So again, we have a chord. You know, a chord goes from one end to the other end of the circle. So we have a chord there, and let's say we have another chord here. Pretend they're straight. So let's say this is 24. Maybe this one's 21. And now we have x minus 9 here, and we'll have x minus 5 there. So find x. Right? If you pause the tape, what'd you get? Right? So we have, in these two chords here, we have 21 times x minus 5. That's those two segments of the chord. And we know it has to equal 24 times x minus 9. Right? And then we just distribute. So we're going to have 21x over here, 21x minus 105. Just doing the math. And 24x over here minus 216. And of course over here we can minus the 21x and to the 24x if we wanted to. We can do the variables first, or you can do it doesn't matter which ones you do. Which one did you do? So let's add. Let's add the 105 on this side. Whatever you do to one side, I'm going to do to the other side. Now I have 21x equals 24x, and negative 216 plus 105. That gives us minus 111. And then we minus the 24x on this side. We'll minus the 24x on that side. Put another line. Then we're going to have negative 3x equals negative 111. Dividing the negative 3 on both sides. And you know now we're going to have a positive. And x will equal 37. Double check the math on that one. So rewind if you have to. Look at the math. Again, that's the chord segment theorem. When two chords intersect, you're going to take the product of the two segments like we've been doing, and they have to equal the product of the other two segments. So that's our video today.